here we go. So hopefully you read some of these things that says, we know how to differentiate sine x and x squared minus 4, but how do we differentiate a composite like sine of x squared minus 4? Well, the answer is chain rule. So let's talk about chain rule. We'll give you the formality, and then we'll give you a shortcut, like always. So you probably won't like the beginning, or maybe you will, I don't know. So example 1, and we'll go real slow. You ready? It says the function y equals 6x minus 10 equals 2 times 3x minus 5. So this is like saying I can write this as a composite function. It's the composition of the function y equals 2u and u equals 3x minus 5. And you guys can see that u is that 3x minus 5. How are the derivatives of these three functions related? Well, if I take the derivative of 6x minus 10, it better be the same thing as me taking the derivative of this guy. So it better, right? That's what I was trying to show in the beginning here. So let me just write y equals 6x minus 10, and then just write y prime equals, well, you know what? I'm not going to write y prime. I'm going to write a dy dx. There's a reason for that. Dy dx equals, what's the derivative of 6x? 6. So there it is. We're done with that. So that's the derivative I better get. Now I'm going to rewrite this part, but I'm going to write it like this. I'm going to go y equals 2u, and I'm going to put u on the side here, where u is equal to 3x minus 5. Are we cool? All right, so check it out. So this y equals 2u, I can take the derivative of y, but I cannot take it with respect to x. I need to take it with respect to u. So write dy du equals 2. Are we okay? All right, now this u over here on this side, I can take the derivative of that, but I cannot take it with respect, well, I'm going to write du over, and I have to take it with respect to what letter? So I'm going to write du dx. Does that make sense to you guys?
I have a question.
Ask.
Okay, so whenever you did the derivative of y with respect to u, you got 2, but whenever you did... Oh, wait, never mind.
You okay?
I said it and then I understood it. Yeah.
Okay. Is everyone okay with the dy du and the du dx? Okay, but what if I told you I don't want dy du and I don't want du dx, I want dy dx? Hopefully you're going to look at it and be like, well, Chav, dy dx is nothing more than dy du times du dx, because I can see that the du's are going to cancel, and that will give me that dy dx that you want. Do you guys see that? And if I do that, dy du, what was dy du? 2. And then du dx was 3. And did I get the same answer that I had over here? Yeah. So what you actually did was chain rule. That's chain rule there. But don't worry, it will get easier. If you miss this one, don't worry. You'll catch up with the next one. All right. Same thing again. So I have this polynomial, and notice, in case you're wondering, are you sure that equals that? Yes. If I go, this is just a side note, 3x squared plus 1, because I know we have issues with expanding factors here. 3x squared times 3x squared, 9x to the 4th. 3x squared times 1 is 3x squared, but you're going to have 2 of those, so plus 6x squared, and then 1 times 1 is 1. So there it is. That's the same as that. Cool? So I'm going to write y equals 9x to the 4th plus 6x squared plus 1. I'm going to take the derivative of this with respect to x, dy dx. And I'm just going to do my power rule. What is 9 times 4? 36x to the 3rd plus, what is 6 times 2? 12x. There it is. That's it. That's my derivative, right? Okay. If I were to rewrite this in terms of, I'm going to change my color, so this is a good place to change colors if you have one. I can rewrite this as y equals u squared. And I can say that u equals 3x squared plus 1. Have I lost anyone? See? This is like u. That's like u squared, right? Okay. All right, let's see. I can take the derivative of u. I can take the derivative of y, but it can't be with respect to x. It has to be with respect to u. Do you guys see that? So the derivative of y with respect to u is just 2u. And the derivative of u over here, so I'm going to write du dx is equal to what? 6x. So then I can say, I'm going to write it right here. dy dx is nothing more than dy du times du dx. So du's cancel out, and that's what's going to give me my dy dx. So I'm going to write 2u, and don't worry. I know maybe some of you guys don't like that letter u because it's supposed to be all in x, times 6x. So at the moment, I have 12ux. And you're probably like, man, child, that looks nasty. Well, I'll get rid of the u in a little bit. What does u mean? 3x squared plus 1. That's what I'm going to plug in. So I'm going to go 12 times 3x squared plus 1. I guess I should write 12x. Let me write 12x. 12x. 3x squared plus 1. Yeah, rewrite the 12ux as 12xu. 12xu. It's the same. ABC is the same as CBA. So there we go. I'm going to distribute 12 times 3. 36. X squared times x. X cubed. 12x times 1. Did we get the same answer? Yes. Oh, yeah. I said 12x, but I didn't write the x. Thank you, miss. All right. So what you just did is this. So if you go to, and if in case you're wondering where all these numbers are coming from, they're coming from the Demana textbook, which is technically our textbook that we use, but, you know, what's up? Yeah, that was just to prove that is true. So now you're convinced, like, oh, chain rule works. I'll show you the best way. So look what it says here. If f is differentiable at the point u equals gx and g is differentiable at x, then the composite function f composite g, which is this, is differentiable at x and blah, 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 blah. And you're looking at it like, what? In Leibniz notation, if you blah, 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 blah. So this is what we were doing. That's Leibniz notation. We're not going to use this. Well, I guess we are when it comes to our benefit. We're going to use this one. So here's how you say this. The derivative of a composite function, so I'm going to write d dx of f g of x. So do you guys agree that f is the outside and g of x is inside of f? Is the derivative of the outside, f, leave the inside alone, times derivative of the inside. And this is why I wanted to bring M&Ms, like the peanut M&Ms. Has everyone here had the privilege of having a peanut M&M? Okay, sorry that I didn't bring any peanut M&Ms. So there are 3 layers. There are 3 layers to a peanut M&M. Okay, this is important, guys. This is important. Focus. There are 3 layers to a peanut M&M, right? The first layer is the shell. Then between the shell, there's chocolate. And then the last piece is the centerpiece is the peanut, right? So whenever you're taking the derivative, I want you to think of M&Ms. You always work from the outside in. So I know no one's ever going to tell you, eat the M&M, but eat the shell first. And then you're going to yeah. All right, so let me see how this works. So here's my M&M. Ready? Example 3. An object moves along the x-axis so that its position at any time t is greater than 0 is given by x of t equals blah. Find the velocity of the object as a function of t. Ooh, I don't even know. We might. Let's see. I don't know. I have a position function. I want velocity. How do I get velocity from position? Yes. This is not physics. I got to do it calculus. I have a position function. I want to find an expression that gives me my velocity at any time t. I have to find the. Oh man. Yeah, I have a position function, and I want to find my velocity at any time t from my position function. I need a tangent slope, so I gotta find the Starts with the letter D. Derivative. All right. So let's just talk basics. The derivative of position is velocity. The derivative of velocity is acceleration. There is a derivative of acceleration. It's called a jerk. The jerk, no, it's not a joke. The derivative of acceleration is called jerk. So if you're mad with your boy or your girl, because we don't judge here, if you're mad at them, you can say you're being the derivative of acceleration right now. And if they don't get it, they're like, you're confusing. What does that mean? Go look it up, and then just walk away. All right.
Can you explain that? Like, can you give us an example of I don't use it now.
Well, let's do this first. All right, here we go. So does everyone agree? All right, guys, let's get back at it. Does everyone agree that to find my velocity expression, I need to take a derivative of this function? All right, so I'm going to put it here on the side. I'm going to go v of t is equal to d dx, or actually d dt, because it's with respect to t, d dt of x of t. That's just on the side, just for your notes. So here we go. V of t is equal to x prime of t, so that means I'm taking a derivative, which is equal, and we're going to go outside in. What's considered in? The argument. T squared plus 1 is the n. So what is the derivative of cosine? Negative sine. That's right. Negative sine. Leave the argument alone. Well, for sine and cosine, you always leave the argument alone. And then you're not done. Now you're going to work with the inside. Times the derivative of the inside. What's the derivative of t squared plus 1? 2t. Leave it alone now. If you want to write it pretty, v of t equals negative 2t sine of t squared plus 1. How do we feel? Yeah, that's it. And then it says, let's have some M&Ms. So, yeah, sorry. Rain check on tacos. Tacos tomorrow?
Wait, tacos tomorrow?
Okay. What do you want? Potato egg?
Yeah.
Bean and cheese? Okay. Potato egg, bean and cheese. Don't have breakfast. We'll have it here. All right. What's the question, miss? Ask. You have to keep... no product. If I were to take another derivative, it's product rule. But you are going to have to use chain rule. You're going to have to use product rule with chain, and we'll see. There's plenty of examples. All right, here we go, guys. Let's keep going. So here's what I was telling you guys to read earlier or to say earlier. All right, guys, focus. It is sometimes helpful to think about the chain rule this way, blah, blah, blah. There's a composite function where the g of x is the inside. In words, differentiate the outside function f and evaluate it on the inside function. G of x left alone, then multiply the derivative of the inside. All that means is take the derivative of the outside, leave the inside alone, times the derivative of that inside. If the inside has another inside, times the derivative of that inside. And you keep going, like an M&M. Shell, chocolate, peanut.
So basically you don't have to reverse core. So you just keep finding the derivative of the inside. You don't have to...
If there is an inside. Look, let's do another problem. Look at example 4. And in a little bit we'll do a triple chain link or example 5. Oh, it says let's try example 3 again with the new outside-inside rule. Okay, let's look at example 3. What was it? Oh, I did do example 3 with chain rule. Never mind. We already did it. Sorry. We should have done Leibniz rule, but that's fine. Example 4. Differentiate sine x squared plus x with respect to x. So here we go. I'm going to write y equals sine x squared plus x. And now I'm going to go y prime. You can say dy dx if you want. What's the derivative of sine? So write cosine, leave the inside alone. Times, now I got to take the derivative of the inside. What's the derivative of x squared? Perfect. This one I would leave alone, right here. Now, here's a side note, in case you're wondering, Chav, how come we never did chain rule with sine x? Well, we did. You just don't know that you did. Look, what's the derivative of sine x? Cosine x, and then you say, okay, what's the derivative of x? 1. Anything times 1 is itself. All right. Here we go. A triple, finally something that looks a little different. Next year's notes, I need to put some more polynomials in there. Next year's notes will be better, but sorry. Well, All right, here we go. Here we go, guys. A triple link chain. So here I want to take the derivative of this expression. So I'm going to go g prime of t equals, take the derivative of the outside, leave the inside alone. So what is the derivative of tan? So I'm going to write secant squared, and I'm going to leave the inside alone. 5 minus sine 2t. Am I done? No. Then I go, what is the derivative of that inside? And I see a negative sine 2t. So what's the derivative of negative sine? Negative cosine. Keep the argument. And then does that have an inside? Yes. What is the derivative of 2t? 2. So making it all pretty, g prime of t is equal to, I'm going to put a negative on the outside, 2. Let's see, yeah, and the rest, secant squared of 5 minus sine 2t, close, close, cosine 2t. From that negative. Well, that is expanding. There's nothing to multiply. You can't multiply by the inside of that. This is the argument. The 5 minus sine 2t. Yes, Alvarez. We did. We took the derivative of the derivative of sine is cosine, leave the inside alone or the argument alone, times derivative of this inside, 2x plus 1. That's it. There is no more inside. It has to be like, see, this one has an inside. Derivative of tan is secant squared, leave the inside alone. Then this has another inside within an inside, see? Then derivative of sine is cosine, leave that inside alone. And then derivative of 2t is 2. Yeah, you're going to see, yeah, we're going to do more. All right, look at this one, guys. And this, yes, ask, what's up? All right, here we go, guys. Look at this one. No calculators. Find the slope of the line tangent to the curve y equals sine to the 5th power x at the point where x equals pi over 3. I think by now we've done enough that we know that to find a slope, you have to take a derivative. Now, for now, because we're rookies, I want to see as soon as you see one of these, I want to see everyone rewriting it sine x to the 5th power like that. Once you become pro, once you become beast, you can start writing the power after the end. So on this case, what is inside? Sine x is inside. Do you guys see that? Yes. So here we go. I'm going to go real slow. Y prime equals derivative of the outside. So bring what down? 5, open parenthesis, leave the sine x alone. Sine x, close it. What power do I put? 4. Am I done? No. Now times the derivative of the inside. What's the derivative of the inside? There it is. Now I'm going to rewrite it. I'm going to write it like this. Y prime equals 5 sine, put a 4 after that, x cosine x. That was the calculus part. Now comes the pre-cal part. Just plugging in a power over 3. I don't know, maybe this one's better because you can see it's the sine power over 3 raised to the 4th power. So, I mean, it means the same thing, but whatever. All right, here we go. Y prime at pi over 3 equals 5, parenthesis, what is sine of pi over 3? Let's see if you guys remember.
Wait. Pi over here. Oh, what happened? No, square root. Oh my. Sorry, child. Oh yeah. That is why. But pi over 3 has a longer.
Cosine, yeah, it's at 60 degrees. Cosine of pi over 3 is a half. And I think we can do this without a calculator, I think. 5. Square root of 3 times square root of 3 is 3. And 3 times 3 is 9. So I see 9 over 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 9 over 16 times a half. All right, finally. 5 times 9. 45 over 16 times 2. 32. I don't see it reducing. It might. Let 45. Nope, it doesn't. 45 over 32 is the slope. By the way, the pre-cal class is having a unit circle quiz tomorrow. So that means you guys are definitely having a unit circle quiz tomorrow. Relax. If you don't do well, we won't count it. But I'm telling you right now, right? That way it's not a surprise tomorrow. Like, you didn't tell us. Like, surprise.
My thing is, if I can see it visually, I don't have a problem. But imagining it in my head, like going like this, I can't do it.
We'll put a unit circle on the back. Blank, of course, so you can visual. All right. So here we go, guys. Let's keep going. Look at example 7. You could do quotient rule on this if you wanted to, guys. But make life simple for yourself. All right, focus, guys. Make life simple for yourself. Look, I haven't taken a derivative yet. I'm just rewriting it. d dx, parenthesis, laws of exponents. I'm going to bring that up. So hopefully by now you're getting really good at exponents because that's all we've been doing lately. 2x to the power -3. Does everyone see what I did? Okay, now I'm going to take a derivative. So now I'm not going to be writing that d dx anymore. So I'm going to put equals, because that means I'm taking a derivative. What do I put in the front? -3, open parenthesis. What do I put inside the parenthesis? To the power what? Am I done? Times what? -2. Perfect. That is the derivative. You probably want to rewrite it. If they gave you positive exponents, you probably want to keep it in terms of positive exponents. So here it is. Negative times a negative is so positive 6 in the numerator over parenthesis 1 minus 2x close it to the power 4. That is my derivative. I was about to say my prerogative. It's from a song, I think, right? It's my prerogative. I think it's Britney Spears, but it might be Janet Jackson. What's up?
That is very different.
Oh, you see these two numbers right here, -2 and -3? The -3 is in the numerator, the -2 is in the numerator, because there's no exponents next to it. So -3 times -2 is a positive 6. I got the -3 from the power rule right there. I brought it down, subtracted an exponent. -3, 1 minus 2x to the power -4, -2, and I multiplied it. It stayed in the top. This and this stayed in the top because this is the only thing that's going down into the denominator. Did I answer your question? Okay, tell me your question again because I can't. I got it from the power rule. That -3, okay, look, y equals u to the third power. dy, -3. Oh, the -3, got it. Where did it come from? You see that 3 here in the bottom? When I picked it up, it turned to a -3. And then I just took the derivative. So u to the -3, dy du equals -3, u to the -4. Do you see that or no? Say it again. Yeah, I just left the numerator alone. Yeah. All right, guys, focus. It's just sometimes I'm trying to listen to two things. Did I answer your question? Okay. All right. Let's go to the next one, guys. So look at this one here. Take 30 seconds, maybe 45 seconds. See if you can answer number 1, and then we'll answer it together in a little bit. Got it? What is the derivative of tan? Yes. Secant squared 4x times the derivative of, so 4. So what's the answer? Yeah. All right, go to the next one, guys. See if you guys can do that one. Take 30 seconds and we'll do it together in a little bit. The first thing I would have done is rewritten it. Did everyone rewrite it like this? Okay, that's the first thing I would have done, guys. Cosine of x cubed plus x squared, that's my argument. Put the whole shebang in parentheses and put a square on it. Right? So here we go. I'm going to go slow. Y prime equals, bring down the 2. Leave everything on the inside the same. Power 1, you don't have to put the power 1. Are we still okay? Now the derivative of the inside. What's the derivative of cosine? Positive or negative? Negative sine. Make sure you use parentheses. X cubed plus x squared, close, close. Am I done? Times derivative of that inside. I ran out of room, so I'm putting it down here. What's the derivative of x cubed? Plus. There it is. Now let's fix it and make it pretty. Y prime equals, I see a negative in there, and I see a 2, so I'm going to write negative 2, parenthesis. I'm going to put the 3x squared plus 2x first. And then I see, yeah, I put the negative. And now I'm just going to put cosine sine. And there's actually another rule in here that we can use, but it doesn't look like they used it, so we're not even going to talk about it. It's pre-cal. Double angle, half angle properties, and all that good stuff. When you get to BC, we'll talk about it. For now, we're good. Look for that answer. What's the answer? I think it's letter C. How do we feel, guys? All right, let's keep going. Now we have a table similar to what we did yesterday, but now we're going to do chain rule. The first few are not, so it's kind of like a review. So it says evaluate the derivative with respect to x with the following combinations given value of x. Okay, so here we go. I want the derivative of 2f of x. The derivative of 2f of x is 2f prime of x. I'm going to evaluate that at 2. So 2f prime of 2. 2 times f prime of 2 is... So my final answer is 2/3. Cool? If you want to get ahead, go ahead. No big deal. So I'm going to take the derivative of f of x plus g of x. That's going to be simply f prime of x plus g prime of x. So now all I'm going to do is plug in a 3. F prime of 3 plus g prime of 3. So let's see. F prime of 3 is 2 pi. And then g prime of 3 is 5. If I make a mistake, please let me know, because I make mistakes all the time. Are we okay? Okay. And I'll slow down. I can see some of you guys writing. What rule do I need for letter C? Products. So here we go. And it's okay if you want to get a little ahead, guys. If you want to, once you finish C, if you want to go to D, go for it. F of x times g of x. I'm going to double underline. Underline, double underline. So that means f of x is my first, g of x is my second. So first, derivative of the second, plus second, that's a g. Derivative of the first. That's my derivative. And now I'm just going to plug in. f of 3, g prime of 3, plus g of 3, f prime of 3. That equals, what's f of 3? F of 3 is 3. G prime of 3 is 5. Plus g of 3 is negative 4. And f prime of 3 is 2 pi. My final answer is 15 minus 8 pi. I'll wait for you guys to. I'm going to do this quotient rule, the one on letter D. I'm going to do that one in black. I can see some of y'all's pencils still moving, so I'm going to give you guys a little break. Cardinals on 3. 1, 2, 3. Cardinals. It's all good, miss. You want to rock.
Yeah.
That was funny, miss. All right, here we go. Bottom. I'm gonna put this in black so you guys can see. D dx of f of x over g of x. What rule am I using here? Quotient. Bottom times right over the top. Yeah, low D high. Minus top times right over the bottom. All over bottom squared. So that's what I'm doing. G of 2. F prime of 2 minus f of 2, g prime of 2. You don't have to show all this work. I'm just trying to be very specific so everyone can see where everything's coming from. So let me see. G of 2. What was g of 2? 2. So 2. And then what was f prime of 2? 1/3 minus f of 2, which is 8. And then g prime of 2, which is negative 3. Am I going to be able to fit it? Yeah. All over g of 2, which is 2 squared. So let's see what we get. We get 2/3 minus plus 8, 16, 24 over 4. Don't leave it like that. I mean, on the AP exam you can. But right now, let's see. Times 3 over 3. So that is 25 to 70, 72 plus 2. So 74 over 3 over 4. And then just bring that 3 to that 4 there, right? So 74 over 12. But that reduces. 37 over 6. Yep, that's the final answer. There it is. 37 over 6. We'll stop. I'll slow down. I did. Happy birthday, Gonzalez! Happy birthday to you. Happy birthday to you. Happy birthday, dear Gonzalez. Elisa. Happy birthday to you. You want to rock. Yeah. You want to rock. That's all I know. All right, Ms. Gonzalez. As a present, you get 100 for the next 3 days. You don't have to do anything. Next 3 school days.
Oh, I thought that was a joke. I thought that was a joke.
No, it is a joke, guys. I can't give 100. I can't give you 100, miss. But get 100 on tomorrow's quiz. Yeah. All right.
No, you said you were.
Hey, guys. Happy birthday, by the way. All right. Hello, Ms. McLaren, if you're hearing this. All right. Here we go, guys. Here we go. Letter E. What rule do I got to use for this one? No. This is not a product. This is chain. This is not F times G. Notice G. Hey, relax. It's all good. Notice G of X is inside F. Do you notice that? Yeah, so here we go. I'm going to write d dx of F of G of X. There's a composite function. Is equal to derivative of the outside. Leave the inside alone. Times derivative of the inside. There it is. See? So I come over here and I'm going to write f prime of g of 2 times g prime of 2 equals f prime. Let's see what g of 2 is. G of 2 is 2. F prime of 2 times g prime of 2. And now I'm going to find both of those. F prime of 2 is F prime of 2, yeah, 1/3. And what is g prime of 2? -3. Yep. You want a chain rule. Chain rule. You want to chain. No? Okay.
We said it at like the same time.
Oh, we did? Oh, I didn't hear that. We're thinking in the same frequency, miss. Do you ever I think sometimes when people are like doing the same work, you start thinking in the same wavelength. Cause doesn't it ever happen like you're talking to your friend and both of y'all are thinking about the same thing and they're like, or you're thinking about the same song? It's because both of y'all are in tune. All right, here we go. Sorry for distracting you guys. Look at this one right here, guys. Rewrite this. This is a chain rule. This is a chain rule. dx, and I'm going to rewrite this as this, guys. Put a parenthesis, f of x, close to the 1/2. Do you guys see that? The f of x is inside. So here it is, and this is why I changed the color so it's easy to see. Bring the 1/2 down. Leave the inside alone. To the power, what power? -1/2. Times what? F prime of x. If you want to rewrite it, here's how it's going to look. F prime of x in the numerator. In the denominator, you put a 2. That's from the half. Square root of f of x. Cool, right? I want to insert x equals 2. Okay, I'll stop, guys. It's going to get annoying after a while, so I'll stop. F prime of 2 over 2 parenthesis f of 2. So I go to f prime of 2. What is f prime of 2? 1/3 over 2. And what is f of 2? 8. So, yeah, let's fix that. 8 is the same thing as 4 times 2. And the square root of 4 is 2. So I have 1/3 over 2 times 2 is 4, square root of 2. And let's move that up. So I have 1 over 4 times 3 is 12, square root of 2. And I don't like that square root of 2 in the bottom. So we're going to multiply this sucker by square root of 2 over square root of 2. And we get rock. 12 times 2. I find it funny, but you guys are probably getting borderline annoyed by it, so I'll stop. That was the last time. I won't do the rock anymore.
Yeah. Okay. Yeah.
Now I have a Lion King song in my head. All right, here we go.
That's still not 36.
Letter G. Oh, letter H is going to take a long time. Letter G. No, letter G is simple. I put a lot of space in there, but it doesn't need that much space. ddx, bring that g squared up. I don't like the 2 being right next to the g there. I'm going to put it like this. You'll see what I mean when I bring it up. I'm going to write it like this. G of x, and I'm going to put the whole shebang, -2, like that. So here we go. Equals, what do I write? -2, leave the inside alone. What power? -3 times g prime of x. So let's fix it. So I'm going to write -2 g prime of x in the numerator. In the denominator, I'm going to write g of x, and that is to the 3rd power. Let's look it up at 3. So -2 g prime of 3 over g of 3 to the third. What was g prime of 3? Was it 1/3 or
Oh,
g
wait,
prime?
no.
5.
5.
So negative 2 times 5 over, and then g of 3 is negative 4, yeah. Negative 4 to the third power. You can actually leave it like that, but it's going to be a positive. 2 times 5 is 10, and that's 64. So that reduces, well, yeah, but negative divided by negative. And it goes into 5 over 32. What do you guys think? What do you nerds think? All right. This one here, if you can do letter H, you can do all of them. I'm going to rewrite letter H. You guys ready? So this is the one where I need your A game. So I'm going to rewrite letter H. I'm trying to take a derivative, and let me see if I can rewrite it. I'm going to write f of x squared plus g of x squared, and then put a giant parenthesis right there, and then that's to the 1/2, and then close it up. Yeah, there's a lot of insides. Are we okay? I haven't done anything, guys. I haven't done anything. All right, what do I do first? Well, the 1/2 down. So I'm gonna try to differentiate. So let's see. The 1/2 comes down. So there's my blue giant parenthesis. That's still my blue there. And then f of x, close, squared, plus g of x, close, squared, my blue. If you have colored pencil, it is a good one for that, or colored pens. What power is it now? Negative 1/2. Am I done? No. Times derivative of the inside. But notice that when you do the derivative of the inside, those insides have other insides. So look, I'm just going to underline it. What if maybe you do it on the side? I don't know. Whatever you think is easier, guys. I mean, I do know, but I'm not saying I don't know. So look, on the side, I'm going to put, and if you're a rookie, I would do this in the beginning, but once you kind of get the hang of it, I would stop doing it. ddx of f of x squared is 2, leave the inside alone, f of x times the derivative of that inside, which is f prime x. Do you guys see that? So here we go. I'm going to write it as 2 f of x, leave the inside alone. If you want to put parentheses, you can, but it's to the power 1, so you don't need it, times derivative of the inside. Do you guys see that? Plus, and I'm going to do the same thing with the g. 2 g of x times g prime of x, close. Are we okay? Now we need to make it pretty. You can actually start solving it right here, but I wouldn't, because a lot of stuff simplifies. Do you see how the 1/2 and the 2's cancel out? Yeah, if you can see that, great. If you don't see that, I'm going to show you a way how you can see it. Now I'm going to write everything in red. This is in my numerator. This goes to the bottom because of the negative 1/2. And remember that 1/2 means square root. Do you want me to show the steps or just do it in one step? Okay, I'll show the steps. All right, here we go. 2 f of x, f prime of x, plus 2 g of x, g prime of x, over 2 parenthesis f of x squared plus g of x squared, close it to the 1/2. And now that 1/2, remember, means square root. So I'm going to rewrite it like this. 2 f of x, f prime of x, plus 2 g of x, g prime of x, over 2 square root f of x squared plus g of x squared. What do you notice? I'll slow down. What number can I factor out from the numerator? 2. Because I can factor out a 2, Can I cancel all the 2's? Yes or no? Yes. Out, out, out. Make sure you write y, because you can factor out the 2 in the numerator. Here we go. They wanted it at 2, so now I'm going to start plugging in. F of 2, f prime of 2, plus g of 2, g prime of 2, over square root of f of 2 squared, plus g of 2 squared. Now I'm just going to get my values from the table, guys. What's f of 2? Yeah, maybe go up here. F of 2, 8. What's f prime of 2? F prime of 2, 1/3. Plus, what's g of 2? 2. What is g prime of 2? G prime of 2. Make sure there's no errors on any of my stuff, guys. All over square root. Let's see, which one was f of 2? 8 squared plus 2 squared. All right, let's see if we can do that. 8/3 minus 6. In a little bit, we'll change that. Square root 64 plus 4, so 68. $68 breaks down to 17 times 4. So I have, let's see, let's do common denominator here. Times 3 over 3. So 6 times 3, 6, 12, 18. So 8 minus 18 is 10. So negative 10 over 3 over 2 square root of 17. Let's pick that up. Negative 10 over 3 times 2 is 6 square root of 17. And we're just rationalizing it. You don't have to do all this work. There is overkill. You could have left it alone right here, really. On the AP exam, you can leave it right there. Multiply by square root of 17 over square root of 17. And we're going to get negative 10 square root of 17 over, what's 6 times 17? 6 times 17. 102. Which reduces to, don't worry, well, we're done. 5 over 51. Negative 5 square root of 17 over 51. Two times negative 3. That g of 2 was 2. G prime of 2 was negative 3. I'm just getting it from here. Unless I made a mistake, but g of 2, right? G of 2 was 2 and g prime, was it g prime of 2? Yeah, g prime of 2. G prime of 2 was negative 3. So 2 times negative 3 is negative 6. No more power. Hold on. There you go. Were you about to celebrate? Man.
Okay, slave. I'm not I forgot to rationalize. Okay, rationalize. Radicalize.
Rationalize.
Rationalize the denominator.
Okay, we're back. Hopefully my laptop didn't stop working. All right, Alvarez, where? Alvarez, you good? Okay. Any other questions, guys? How do you feel about today? Okay, now we haven't done enough chain rule. We just did the basics of chain rule. We haven't done a product with chain rule or a quotient with chain rule. We haven't done the extremes yet. So I would recommend you do not do, there's two deltas. You should probably only work on the first delta and not the second, because the second one will probably give you headaches because it's advanced chain rule. So just take care of the first delta and you're good. Cool? And there's a UH due. Is it due today? No, it's due tomorrow, I think. The attempt is due today. Oops. I thought it was due yesterday because I put the grade in already. All right. Hey, relax, guys, relax. Happy birthday.